Good morning. Once again, this is Mr. Grenfell, Professor Grenfell, coming to you from RCC Math Department, and we are continuing in our statistics class, Math 12 at RCC. So, go Tigers. This video is on example 10-9. This is going to be an example for finding the equation of the regression line. So we just introduced the idea of the line of best fit for our, let's just say the scatter plot of paired data that we're looking at. And let's remind ourselves the equation for this. So y prime, remember that's the symbol that we use for our predicted value of y, is equal to a times x plus b, where these a and b are given by these formulas. So a is given by that horrible expression there. And then similarly, and b is equal to n times the sum of all of the x's times y's minus the sum of all of the x's times the sum of all of the y's, all divided by n times the sum of the squared x's minus the sum of all of the x's squared. Remember, those are two different things, so you got to kind of remind yourself by saying them a little bit differently. That's what I always try to do. Now, I can give you some tips and advice on what to do when you're trying to keep track of and memorize all these formulas and recall what the correct one that you're supposed to be using in that circumstance is. And what I do, one way that I help myself remember things, is I remember these formulas in chunks. And I try to say, okay, these two formulas right here for A and for B, they have these commonalities, right? They have the same denominators. In the top and the bottom, they have this particular kind of format. Notice this one, that's the same as one of the calculations that we use in computing the correlation coefficient, R. This one's a little bit different than the things that we've seen in the past, but one kind of way that we can remember formulas a little bit better is notice that there are repeats in terms of the basic structure in a lot of these formulas, right? There's similarities. And so if you can think of those are nice because those will help you remember what the other formulas kind of look like. Then it just becomes a matter of keeping track of what the differences are. So these are the equations that we're going to be using. We have already looked at this information. It says to find the equation of the regression line for the data in example 10-4 and graph the line on the scatter plot of the data. So in example 10-1, I believe it was, we created a scatter plot for this data. In 10-4, we calculated the regression, the correlation coefficient, R. I think that's why I said regression. Don't hate me. And then after that, in example 10-7, and then actually again in example 10-8, after we did the scatter plot, then we calculated our correlation coefficient, and then in the subsequent examples after that, we tested the significance of the correlation coefficient, and if all three of those items in that checklist indicate that there is a linear relationship between these variables, then what we're going to go ahead and do is proceed to then come up with the equation for the line of best fit so that we can use that to make predictions about what we expect for the y value if we use or if we plug in a particular x value. So we'll go through the procedure of coming up with the coefficients for this equation, for this line, so that we can put it all together and graph right? So we have our X column and we have our Y column. We're going to then go ahead and create a column for X times Y and fill in all of those values using remember using the X value here times the Y value here, and that gives us this value here, right? And then similarly, we're going to go ahead and say, here's one for X squared, and then last, we've got this one for Y squared. And we're going to go ahead and add up all of these. That's what the down arrow indicates, or that's what it's supposed to mean. And then once we do that, we'll sum up all of these values, the sum of the X values by themselves, that's the sum of the Y values, that's the sum of all of the X's times the Y's, and this is the sum of the squared X's, and this is the sum of the squared Y's. Because all of those values are going to be used. Well, we already used all of them when we were calculating R. Now we're going to use them again to calculate A and B. And those values, those numbers, are going to be the coefficients in our equation. And here are the values. I just went back to the spreadsheet that I used to record all of my scratch work and just recopied those down. All right, so there's the equation for A. Remember, never miss an opportunity to try to, just reinforce that memory or memorization. And so I actually did this not with my calculator, I did this with my spreadsheet. So I essentially just told it, do this one for sum of Y times this one here for the sum of X squared times this. That's why I substituted in 153.8 and so on and so forth, times the sum of X times Y, dividing by this. The 6 came from the sample size, and then there's this 5859.26 again here. That is the sum of the X squareds, and then here is the sum of all of the X's. Where did that go? There it is. And then we square it after we add it all up. And so what you should be getting after you feed all of that into your calculator, or what I got after I had my spreadsheet do the calculation for me, and then round to 3 decimal points, that was going to be 0.396. That's what we got for A. Now for B, just same thing. We write down the equation that, the formula that we use to find B. Then we've already got all of these values to plug in. So that's the next thing we'll do. And so like we did above for A, we just go ahead and substitute all of that in. And then I'll finish the calculation off. So we have 0.106 for B. And now I just noticed that I had written the equation for the regression line as AX plus B, because that's what I perceive as making sense. However, the book has their notation switched with mine. So essentially, they're going to say this is A plus B times X. Okay, it doesn't matter that we have the X in the first term versus the second term. What does matter is that in this one, I would have put the incorrect coefficients for this. So I may have to put something in the comments for the last video that I got the formula wrong. Make sure you pay attention to that. And so again, to just reiterate, our equation for the line of best fit is going to be in this form. It's going to be something plus something else times X. All right. And notice I just got it confused in terms of which one we were saying is just the constant, and then which one is the constant times the X. So here, substitute in 0.396. That was what we had for A. So that is the actual, that is not the slope, that is the initial value for y when x is equal to 0, the initial predicted value. Then the slope of this equation is 0.106. So that indicates how steeply it is either rising or falling. In this case, every time we move x over by 1, the y value is predicted to increase by exactly 0.106. So if it just asks you to find the equation of the regression line, that would be our final answer. Y prime is equal to 0.396 plus 0.106 times x. It asked us to go ahead and graph the line of best fit, or the regression line, if you will, on our scatter plot. So I'll go back and recreate the scatter plot real quick. Okay, so there is our scatter plot. I just quickly recreated it from the data that we were given. And so there's all the points. And notice it appears as if there is a linear relationship. And that's what we tested. We calculated the coefficient. We looked at our graph. And now we've gone ahead and actually found the equation for our prediction line, our regression line. Now, how do we do that? How do we graph this equation? A simple way to do it is simply take any two x values, plug them in to the equation, one at a time, of course, get the corresponding y values, and plot those 2 points. So that's what I did. I plugged in 8.5 into our equation, which was y prime equals 0.396 plus 0.106 times x, and I got out 1.297. So there that is on a graph. And then similarly, I went ahead and did the same thing. I substituted in 63 for x, and I got out 7.074. So notice this value over here was a little bit larger than the observed value of exactly 7.0. This value right here, the expected value, is the green one, and that's a little bit it's a little bit smaller than the actual observed value. So it takes how many points to define one straight line? 2. That's right. There's exactly one line that goes through any 2 points. And so that's what we'll do now. Just go ahead and connect up these 2 points with as best as I can do, given my shaky hands. Okay, well, that was close. Let's clean this part of it up. All right, no, not too bad. And there we have it. So that is how we will, first of all, find the equation of the regression line, and then that is a little extra on how to graph the equations of lines.